I have parachute pants. Don't worry about that. It's too hot.
I was wondering.
Yeah?
Okay.
That's so good.
Alright. As a little introduction to day 3, before we start going through the notes, day 3 is basically the reverse of what we did on day 2. Converse. Aha. So, on day 2, we learned that if we have parallel lines and a particular angle relationship, then we can say that they are either congruent or supplementary, right? You first have that the lines are parallel, and if you have that condition, then you know that corresponding or congruent, alternate or congruent, and consecutive or supplementary, right? We're going to do the converse of that now. So now, instead of having parallel lines first and the angle relationship second, we're going to have the angle pair relationship first and then conclude that the lines are parallel. So we're doing the reverse of what we were doing last time. So notice that all of the pictures that we have in this lesson don't have those little parallel marks. Remember the little triangles or arrows we put on the lines to show that they're parallel? You're not going to see them here because we don't know that the lines are parallel. We're trying to prove that they're parallel using the angles. So this is the reverse of what we were doing last time. Okay? So let's think about it. If we have corresponding angles, if we look at our picture and I see corresponding angles, what needs to be true about them for the lines to be parallel?
They're from the same thing.
They're measures.
They're congruent.
They're congruent. So if you guys see corresponding lines, if you know that they're congruent, then the lines are parallel. That's the reverse of last time. Last time was they were parallel, therefore they're congruent. Now it's if they're congruent, then they're parallel. Converse. What about alternate angles? If you spot in your picture that you have alternate angles, what's their measure relationship going to need to be for the lines to be parallel? Congruent. Henry, you should at least be writing something. Okay. So the corresponding should be congruent, the alternate angles should be congruent. What about consecutive? If you see consecutive angles, what should be true about them? They should be supplementary. So it's the same exact idea we were working with last time, except we're checking the angles first and then getting that the lines are parallel instead of checking the lines are parallel and then solving for the angles. Okay? So we're going to practice that with this chart right here. I have a bunch of pictures. We're going to take a look at them. We're going to figure out what the relationship is between the angles, and we're going to see if it's correct. Are they actually congruent? Are they actually supplementary? And based on that, we'll figure out if lines are parallel. So notice I have 3 options, yes, no, or NEI. NEI stands for not enough information. That would occur when you guys have vertical or linear pair. So if you guys want to write that, I don't remember if I have it anywhere else, but if you want to write next to the NEI, if you have a linear pair or vertical angles, that's not enough information to prove the lines are parallel. So again, for the NEI, you'd spot vertical angles or a linear pair. That's when you would use NEI. Vertical angles and linear pair are not one of our relationships with parallel lines. So let's take a look at this one right here. All right, I don't know that the lines are parallel because I don't have the little symbols. What's the relationship between those 2 angles? What types of angles? They are consecutive interior. What should be true about them in order for the lines to be parallel? They should add to 180. So take your calculators and do a little bit of mental math. If you add those 2 together, what do you get? Okay, so if I ask you the question, are those 2 lines right here parallel? It would be yes, they are. Like this. When you're justifying your angle, your answer, you're going to tell me what the angle relationship was, and you're going to confirm that their measures are what they're supposed to be. So this one you'd say consecutive interior are supplementary. That's our reasoning. I have consecutive interior, and they have the appropriate measure relationship. They're supplementary. So yes, and that's why. Okay? What about the second one over? What's the angle relationship between those 2? Well, they do have an angle relationship. It's just not one of the ones we were talking about before. What would you call these angles? Well, more specific, adjacent. Is there a special type of adjacent angles? Linear pair. They're adjacent to make a line. That's the definition of linear pair. Is linear pair enough to prove parallel lines? No, that's what I was just talking about with the NEI. So if you guys notice that the relationship you're using would be a linear pair, you would circle NEI and say linear pair insufficient. Insufficient proof to show that they are parallel.
That will require on the quiz.
Yes. If you spell it wrong, it's okay. Just say linear pair. You could say linear pair is not enough to prove that they're parallel, or you can just say linear pair insufficient. Doesn't prove that they're parallel. So again, the two situations for NEI would be linear pair and vertical. So make sure you're looking at those. All right, what's the measure, sorry, the angle relationship between this 128 and that 62? What types of angles are they? Consecutive exterior. They're on the same side of the transversal, but they're outside of the two lines. What should be true about their measures? Check real quick. Are those supplementary? Do they add to 180? What do they add to?
190.
190. Is that supplementary? So if I ask you the question, are these two lines parallel? You would say no. And the way that you defend that is you still tell me what type of angles they are. They are consecutive exterior. But instead of being supplementary, they are not supplementary. That's why the answer is no. The lines are not parallel because these angles are not supplementary. Huh?
I want to say, like, since they're supposed to be supplementary, I'm writing they're not. So that's kind of confused.
No, don't tell me like what's supposed to happen. Tell me what is happening. So if you see that they are supplementary, write that. If you see that they're not supplementary, write that. Don't tell me what's supposed to happen. Tell me what is happening. All right. What about these? The little boxes. What kind of angles? They are alternate exterior. What should be true about their measures for them for these lines to be parallel? Are they the same? Okay. So then, yes, those two lines that we're looking at, those are parallel because our 90-degree angles that are alternate exterior. You need to tell me what the relationship is. They are congruent. What about the one on the end?
Yes.
What kind of angles are those? Do those prove parallel? So this one would be NEI because vertical angles are insufficient. These lines very well could be parallel, but I don't have enough information to determine that. Vertical angles are not enough. That's what insufficient means. Okay. First row, good with everybody? Questions on any of those? Okay. Second row. What kind of angles are the ones that are labeled right now? Alternate interior. What should be true about their measures? They're supposed to be congruent for the lines to be parallel, are they? No. So are these lines parallel? The answer is no, they're not parallel. And the reason is the alternate interior angles are not congruent. All right. What about this next one? The 27 and the 153. They don't have a relationship, but that doesn't mean that we can't answer the question. What did we do last class when they didn't have a relationship? We shifted the angles to where it would be more helpful, right? So what could I do to make this picture a little bit easier? Could you move the 27? You can move the 27 using vertical angles. You can move it inside. So go ahead and do that. Write another 27 in the vertical angle. Yeah. No, you could also move the 153 using vertical. Doesn't matter which. Pick one of your angles and use a vertical relationship to move it. When you do that, you should notice that the angles become consecutive. And what should be true about consecutive angles? So check. Do those numbers add to 180? Yes, they do. So are these lines parallel? Yes. Because well, I chose consecutive interior because I moved the 27. If you move the 153, then you'd say consecutive exterior. It depends on which angle you want to move. So consecutive interior or exterior, depending on what you do, are supplementary. All right, you guys good with these so far? All right, do the last year on your own, please. Make sure you answer the question and tell me why. Alright, what do you guys think about this one?
Okay.
What kind of angles are they?
Alternate interior.
Corresponding.
They're corresponding.
Oh, I moved it. I was like,
Don't move them if you already have a relationship.
Oh.
I mean, you can if you want to, but why? If they already have a relationship.
but
You
then
could move the one member to alternate interior if you wanted to, but in any case, what's supposed to be true about the measures of corresponding or alternate interior angles if you move them? Are these angles congruent?
No.
So are these lines parallel?
No.
You'd say no, because corresponding, or if you did the extra step of moving the angle to alternate interior, are not congruent. Whatever valid relationship you chose. Alright, what about the one off to the side? Do those have a relationship currently? Currently they don't.
You gotta move that one.
So you move, well you can move either of them. You can move the 89 over here, or you can move the 91 in, right, using vertical angles. Whichever one you choose to do, the angles become consecutive, either interior or exterior, depending on which method you want to do. And those angles should add to 180 if these are going to be parallel, but do they? Yes, they do. So these lines are parallel. I said consecutive exterior because I moved the 89, but if you move the 91 in, then it'd be consecutive interior. So it really just depends on what you guys want to do. And they are supplementary. What about the last one? It's not enough information because they're linear pair. Linear pair are insufficient to prove that lines are parallel. So make sure you're looking out for those. The vertical and the linear pair, those are not going to prove parallel. It's not enough information.
Still, I don't know why I put the 8 down across. But yeah,
There, here.
no, down.
But you can't do that unless lines are parallel. So you don't know the lines are parallel, so you can't make a jump like that. The only way that you guys can move angles is by using vertical and supplementary, or linear pair. That's the only way you can move them in a diagram. So you can't assume that they're parallel. Okay? Questions on that? Right. That's just one type of question they could ask you about the proving stuff. They could also ask you these kinds of questions. These look really similar to last class, right? The directions are going to be slightly different, though. Oops. Well, hold on. Notice the directions say find the value of x that makes J and K parallel. What do you notice about these pictures? Do you guys see any parallel line symbols? No. In last class on day 2, all of our pictures had the parallel line symbol. These don't. Okay? We don't know that they're parallel, we're trying to force them to be parallel. So the question says, what does x need to be to make the lines parallel? Basically, you're just going to treat it exactly the same way as we did last class. You need to figure out what the angle relationship is. If I want the line to be parallel, I have to force the relationship to either be congruent or supplementary, depending on what the angles are, and then you write an equation and solve. So it's exactly like lesson 2. The directions are just okay? So take a look. What kind of angles are 3x plus 17 and the 4x minus 12? They're, well, the type first. They're corresponding. What do their measures need to be in order for the lines to be parallel? Congruent. So we're going to force them to be congruent. We're going to pretend that they are congruent so we can figure out what x that would be. So I'm going to write 3x plus 17. Sorry, I need to kind of be in front of the board as I'm writing so it doesn't mess up. Is that a 12? Okay. So because they're corresponding, I'm going to go ahead and set them equal to each other and then solve. So if I subtract the 3x over here and then add the 12 over here, so even though the lines don't have the little parallel symbol, the directions tell us we're allowed to assume that they are parallel. If you don't have any directions telling you that you're allowed to assume that they are parallel, then you cannot. But the directions say that we can, so we're trying to force them to be parallel. All right, what about these angles? What kind of angles are those?
Alternate exterior.
Alternate exterior, and for the lines J and K to be parallel, what needs to be true about their measures? They need to be congruent. So I'm going to write the equation. 3x minus 5 equals 2x plus 1. That. And then I'm going to solve it. So I use some algebra, pull the 2x over here, add the 5 over there. 6. Yep, we did that. Alright, I'm going to change colors. Oops. Alright, so over here, this one's a little more complicated, right? I'm trying to prove that J and K are parallel, but I have two other lines that are confusing the picture. So what I want to do is trace the two lines that are supposed to be parallel, like this. We're showing if we want those two to be parallel, so I'm going to trace them. I didn't have to do the highlighting in the other picture because it was already simplified. This one's a little more complicated. Which one of those lines do I want to be the transversal? The one that's more vertical or the one that's slanty? I want this one.
Yeah.
I want that one. So you're going to pretend that that other line isn't even there. You can ignore it or you can redraw the picture without that line. In either case, I'm talking about this angle and this angle. What's the angle relationship? Hold on, types of angles first. They are consecutive exterior. Consecutive exterior. And what do I know about their measures if they're consecutive exterior? They should be supplementary. So I'm going to write my equation 140 plus 5x minus 5 equals 100 because they're consecutive exterior. Consecutive angles should be supplementary to force the lines to be parallel. So when I solve, I get 5x is equal to 45. Is that right? So x would be?
9.
X is 9. Okay? So we solve them the same way as we do in lesson 2. You just have to make sure you read the directions to understand what the implication is. Are the lines parallel or you're trying to force them to be parallel? But the process is the same. Questions? Alright. These next questions right here are very important. Right? Look at the directions. What do they say? Okay. Solve for x, then determine if the lines are parallel. Is there anywhere in the directions where they're telling you can assume that they're parallel? No. So we have to be careful with this one. Give me a second. I'm trying to scroll. Can I have my mouse back? Apparently not. Alright, so I'm going to have to write a little bit low on the screen. Alright, so I'm trying to solve for x. I am not allowed to assume that the lines are parallel because it doesn't say to do that in the directions, and I don't have the little parallel symbols. So, my question for you is, if they're not parallel to begin with, and I can't assume that they're parallel, can I use any of the angle relationships we learned in the past 2 lessons? Can I use corresponding angles are congruent? Can I use that alternate angles are congruent? Can I use that consecutive or supplementary? No. That only works if the lines are already parallel or if the directions give you permission to assume that they are, which is not happening here. So can I say that x plus 20 is equal to 2x minus 30? No, you cannot. So what's the only way that I could solve for x in this picture? You have to fall back on the old relationships. Vertical. You have to fall back on the old relationships that we learned in chapter 1, where you know that vertical angles are congruent. So I can still write an equation, I just can't use any of the stuff from this unit, because they're not parallel. Okay? So what's the equation I could write? Sorry, I have to stand in front of the board for a second. 74 is equal to 2x minus 30, because vertical angles are congruent. Fall back on the old relationship. So when I add the 30, I get 104 is equal to 2x. And then x is equal to 52. So again, if you do not know that the lines are parallel and the directions don't let you assume that they are, like up here, then you cannot use corresponding alternate or consecutive. You can only use your vertical or linear pair, like in Unit 1. Now, I solved for x. Cool, that was half the question. The rest of it wants to know if the lines are actually parallel. How can I use x to know if the lines are parallel? You can plug it in. So if I plug it in here, what do I get? 2 times 52 is 104 minus 30, 74. Well, we knew that because it was vertical, right? So know that this is 74. If I plug it up here into the x plus 20, what do I get? Okay. So if I ask you if these lines are parallel, this is now going back to what we were doing in the first chart. What's the relationship between these two angles? Corresponding angles should be, are they? So are these lines parallel? No.
Which right parallel?
I'm gonna write, hold on. Parallel. Not. Parallel. So I've said it a couple times already, but it won't hurt to say it again. You cannot use corresponding, alternate, or consecutive angles to solve like we've been doing in the last lesson, unless the lines are parallel or the directions tell you that you can pretend that they're parallel, like we did up here in the section above. If you don't know or you don't have any foundation that they're parallel, you have to use vertical or linear pair like we were falling back on in Unit 1. And then if you're trying to confirm, then you can check to see if the corresponding are congruent and that kind of stuff like we were doing in the first exercise. So you have to make sure that you're aware of the difference. What, this next one? Okay, so we're doing the same kind of thing here. Same thing. Do you see the parallel marks? Do you see the directions that you're allowed to make them parallel? No. So I cannot assume that they're parallel, so I can't use corresponding, consecutive, or alternate. Do I have any vertical angles to use like last time? No, no vertical angle. So what other relationship do we know from Unit 1 that I could use? Linear pair. You see a linear pair? These two? Okay, so sorry I have to stand on the board, but you can write 5x minus 4 plus 3x is equal to 180. So that's the definition of linear pair. They should be supplementary. All right, how do I solve this?
And just add the x's.
Okay.
This side.
What's 184 divided by 8? What is it? 23. Okay, so x is 23. So cool, we did the first part. Now we need to see if these lines are parallel. So I'm going to plug the x in. So what would I get for this angle with the 3x?
69.
Okay. Does that angle have a relationship with the other one? What kind of angles are these? Alternate interior. If these lines were to be parallel, what should be true about these angles? Are they congruent? So are these lines parallel?
Yes.
Yes, they are. That's how you, oops, sorry.
Why don't you plug it into that x and the other x?
Because this doesn't have a relationship with the number that already exists. Oops. Oh. I tried. Push those together, that's parallel. Alright? So again, that's how you do these problems. You solve for x first and you plug it in to see if you can get the relationship to work out for parallel. Sometimes it doesn't, in which case it would not be parallel. Sometimes they do. So make sure you guys are reading the directions very carefully for those. Alright, this next page is going to go quicker. There's not as many concepts on here. So if you turn the page, I have two more ways so you guys can see that lines are parallel. The first one's kind of dumb because you already know how to do that. It's just another way of representing it. And then the second one is a little bit more interesting. So the first one says a transversal is perpendicular to two lines if and only if those two lines are parallel to each other. So that's this picture right here. They're saying that the transversal is only going to be perpendicular to both of them if they are parallel to each other. And we already, this is just a fancy way of saying if corresponding angles are congruent, then the lines are parallel. Or if the lines are parallel, then the corresponding angles are congruent. It's really just the same idea. They're just making it specific for 90-degree angles, but you guys should know that already. If the corresponding angles are congruent, the lines are parallel and vice versa. So that's just a fancy way of saying that. Bringing perpendicular into the picture. This is the one that's more interesting. All right, how many lines do we have? 3. So for this one, do you guys remember the the syllogism? Remember that we learned from Unit 2? If P to R, then R to Q, therefore P to Q, or P to R, and you write the statements out. This is the same thing but with lines. If A is parallel to B and B is parallel to C, then by the transitive property, A is parallel to C. See how they have the B in common, and then you jump from the beginning to the end, just like a syllogism. Same thing works here. So if I know that A is parallel, well, I have different letters in here. But if A is parallel to C and C is parallel to B in this picture, then I can say A is parallel to B. So we use the transitive property sometimes to jump across a picture. You can go from the beginning to the end and jump over the middle line, as long as you know that both of these are parallel to that. So let's take a look. Why would A be parallel to C?
Why would it?
Yeah.
Because
Because the alternate interior angles are congruent. Sorry, that's a symbol for congruent. My word shifted. There you go. It's an equal with a squiggle on top. It's a symbol for congruent. Right? Why would C and B be parallel?
Because
What does 143 plus 37 equal? So is that supposed to happen? Yeah, which is supplementary. So consecutive interior are supplementary. So I know that A and C are parallel because of that. I know C and B are parallel because of that. So how could I say that A and B are parallel? That little symbol is parallel. You would just say transitive property. Yep. Sorry, my writing's going to start disappearing now. The transitive property. I'm not sure I can make it stop doing that. Can't. So if you ever want to jump from one parallel line to the other, you just use transitive. Okay? We don't use that often, but just so you know, there you go. Alright, so I have a question for you guys. I call these pictures hashtags for obvious reasons. So what I'm going to do is I'm going to have you guys look at this picture. I'm going to give you two angles that have a relationship. I'm going to ask you which lines would then be parallel based on that. So this is where highlighting is also particularly helpful. So if I say that angle 6 and angle 7 are congruent, which lines would be parallel? They're named with letters. Which ones? N and M. You guys see why?
Why not A and B?
Good question. Right. What's the transversal for 6 and 7?
4, 6, and 7.
The transversal is the line that they have in common and it's resting on.
Oh.
The A. So can A be one of the two parallel lines if it's the transversal? No. So that's what you do with these questions. You find the transversal, the line that they have in common. Whatever two lines it's crossing, those are the parallel ones. So find the transversal, the one that they're both resting on. The lines that that's crossing, those are the parallel ones. Okay? Okay, switch to 4 and 7. I know that angle 4 and angle 7 are congruent. Those are corresponding angles, right? What's the transversal that they're both resting on? M. What are the two lines that it's crossing? A and B. So those are the parallel ones. Pretty straightforward. Find the transversal, whatever lines you're crossing with the transversal, those are parallel. 7 and 9. Those are alternate exterior. What's their transversal? What's the line they're both resting on? M. So then what are the two parallel lines? A and B. Because the transversal is crossing those two lines. Now I know that 6 and 5 are supplementary. Those are consecutive interior. What's the transversal? So what are the two lines that are parallel? N and M. Okay? So the trick for that one, if you want to write some notes, the trick for that is find the transversal, the line that they have in common. The two lines that the transversal is crossing, those are the parallel ones. Okay? That's the basic process. We're going to talk about hashtags. Everybody good with that? Cool. All right, we're going to learn about two different diagrams here. One is, I call them hashtags and fences, based on their appearance. So a hashtag is when you guys have at least 2 and 2, like this, like a tic-tac-toe board. You can also throw a third line in sometimes. I want you guys to take a second and write down what I have on the board. Write down what I have on the board, some directions on how to approach hashtag type questions. Pick 2 lines, sorry, that should be plural. Pick 2 lines and a transversal that has 2 angles on it. If an angle relationship exists correctly, the lines are parallel. And then in addition, use vertical or linear pair to add info. Write all that down.
No. And today,
Write it down, please. Yep, write down what's in red. Use linear or vertical, sorry, vertical or linear pair to add info.
Bless you.
Okay, so I'm going to explain what I mean by this. So when you guys have a hashtag, the question most often is going to be which lines are parallel. That's usually the question they ask. They have this diagram with all sorts of lines crisscrossing. You're going to say which pair of lines are parallel. It could be one of them, it could be both of them, or it could be none of them. Okay? Or if they have an additional line in there, it could be all sorts of different combinations of lines. So the way that you're going to do this is you're going to pick two lines that you like, as long as it has a transversal that crosses that has two angles on it. So what I mean is, like in this picture, do you guys see a transversal that has two angles? Like C, for example. This might be a transversal you would use, and then A and B. So you want to narrow down the part of the picture you want to look at. So we're first going to look at A and B being the two lines and C being the transversal. Once you have that in your head, you're going to check to see if the angle relationship is valid, like we were doing on the first page, and if it is, those lines are parallel. If it's not, they're not parallel, move on to try another pair, okay? So take a look. What's the angle relationship between the 100 and the 75? What kind of angles are they? Consecutive exterior. What should their measures add up to? 180, do they? So would A and B be parallel? Would A and B be parallel? No. So we know that A and B are not parallel, so we have to leave that off. Now we're going to try the other ones. We'll try the other ones, okay? So we know A and B are not. So now are there any other transversals that have two angles on them? D, okay. You could look at D as a new transversal. I would erase my previous line, but I'm terrified that it'll mess up the technology. So now we're just looking at D, all right? What's the relationship between these two angles? Currently, there is no relationship. But could I use vertical?
Yes.
Can I move an angle right here? Okay. Now these angles are supposed to be supplementary, but you guys don't have any measures. So that's not enough information right now to see if they are parallel. So we don't have measures right now, right? Well, you remember you can't switch if they're not parallel. We don't know if anything's parallel. Okay, don't assume parallel because I haven't told you that. What about these two angles right here? What would you say their relationship is? Corresponding. Do you guys see how these double arc angles are corresponding? What's the transversal that they're both resting on? B. And what are the two lines that this is crossing that has those angles? Okay, so what do I know about D and E? No, parallel. D and E are parallel. And what angle relationship did I use? Corresponding. I used corresponding angles, the double marks here. Those are corresponding angles that tell me that D and E are parallel. Do you see any other corresponding angles in the picture? Right here? These two? You see those? This is the A is the transversal. What are the lines that it crosses? So what do you know about C and D? No, C and the lines. Lines C and D are parallel because of corresponding angles. Now I don't have any other angles to work with, but I have one more set of parallel lines.
Where?
Exactly.
Oh, C and E,
Why?
because C and D are parallel and D and E.
Yep, that's called the transitive property. They were just looking at the top. See how D is both parallel to E and C? If two lines are parallel to a common line, then they're going to be parallel to each other. So E and C are both parallel to each other by the transitive property. So that's something you want to make sure you're looking for. If you see a letter in common, then you can say that the other two are going to be parallel. All right, the next one's a little bit simpler. It's actually a true hashtag. We have two options. We could either say A and B are parallel, or C and D are parallel. Or both or neither. So what's a transversal that has two angles on it?
C.
C? Okay. C does. Right. Do those angles have a relationship? Not currently. Can I shift some angles around maybe? Could have put a 20 right here maybe. Okay. With the 20 there, what's the relationship? Consecutive exterior, which are supposed to be, does 20 and 170 add to 180? Nah. So which lines are not parallel? A and B are not parallel. They're not. We've confirmed that A and B are not parallel. Now we have to check to see if C and D are. What transversal could I use? B? Let's take a look at B. Do you guys see how B has two angles on it?
Yes.
Okay. That's important. That's why I said up here you need to make sure your transversal has two angles on it. Do the 170 and 10 have a relationship right now?
No.
Could I move one of them maybe? Should I bring the 170 here?
Yes.
There's
What do you know about the 170 and the 10 now? They equal 180 and they're consecutive. Is that supposed to happen? So what do you know about C and D?
Parallel.
They are parallel. Because consecutive interior are supplementary. You do need to defend your answer like we were doing in the first part of the notes. So again, with the hashtags, I know it's confusing with the lines going everywhere and all that. So that's why I say one at a time, pick a transversal. You can even draw the picture again off to the side if you have room. Pick a transversal, check to see if the angles are working, and confirm if the lines are parallel or not. If they're not, try a different side. You're just going to work through the picture that way. That's how we do hashtags. You won't normally see these ones with the three. They're usually 2 and 2, like that. Okay. Now these are fences. I call them fences because you have like fence posts and then one transversal like that. So the way, go ahead and write this down. The way that you work with fences is you guys find all of the measures on one side of the transversal and look for corresponding angles. This one's a lot easier. So go ahead and write this down. Find measures on one side of the transversal, parentheses, using vertical or linear pair. And then you look for corresponding angles. Go ahead and write that down if you have it there.
all fences have two across from it. Fences have like, you go across like that, there's two going here, and then there's one here.
That's good. This is just the top. It's not a perfect analogy.
Oh. I'm so old.
Oh, no. All right. So what we're going to do for these two pictures is you guys are going to pick your favorite side of the transversal, the left side or the right side or the bottom or the top, depending on whether it's vertical or horizontal. So if we look at the example on the left, what do you think is your favorite side of the transversal, the left or the right? The right side. That's where all the angles are. So what you guys are going to do is use linear pair to fill in the rest of the picture. You cannot use corresponding angles because you don't know if the lines are parallel yet. The directions are going to say, are the lines parallel? Or which lines are parallel? So you can't assume that you have parallel right now. So all I can do, that's why I put this in parentheses, all you can do is use vertical or linear pair. So I have a 110 right here. What would go next to it? Nope.
Wait, no,
These are a linear pair, so what would go next to it?
70.
Ooh, okay. Hold on. 70. Okay, so we finished that linear pair. Drop down a little bit. I have another 110. What would go under that? Cool. All right, the 110 is right here now, so what would go above that 110? Cool. And And then I have a 70 right here. What would go above that? Okay, so you have a bunch of 110s and 70s. Once you have all the angles filled out, now you're going to look for corresponding angles. Do you guys see any corresponding angles that are congruent? Where? On lines A and B? So what does that mean about lines A and B? They're parallel. So A and B are parallel because you're corresponding. You see any other pairs of corresponding angles that are congruent?
C and D.
C, nope, not C and D.
B and D?
These two? The 110 and the 110?
Yeah.
B and D? All right, so B and D are parallel because of corresponding. They both have the 110 resting on top. A and what? A and D?
Yeah.
See how A has the 110 resting on top and so does the D? Corresponding angles? You could say corresponding angles or you could also say transitive because if A is parallel to B and B is parallel to D, then A is parallel to D. That's a transitive property, just like our solar system. Are there any others? Does C come into the picture at all? No, C kind of messed it up because it has the 70 on the top instead of the bottom, so that's it. That's it. So all these are by corresponding. Corresponding, corresponding, corresponding. All right, this next fence, you guys pick. What's your favorite side of the transversal, the top or the bottom? Top? Top, bottom?
Either.
I heard top first, I think, so we're gonna stick with the top. So what you guys need to do is take all of the angles along the top and find out what their measures are. You can use the ones on the bottom and shift them up. You can use vertical. Yeah, so for this one we're going to use vertical and linear pair. So how can I use this 99 to help? It's vertical to this one, so I can write a 99 right here because they're vertical. What would the angle next to that be? How would I find that?
It's 180 180 minus 90.
Yes. 180 minus 99, which is 81. Again, you use vertical and linear pair sometimes. So I shift the 99 up and then I use my linear pair. Now for this 82, I have to use a linear pair to find the other angle. So 180 minus, that would be 98. Okay, I shift the 96 up using vertical, shift it up on the top side of the transversal. Then I use a linear pair to figure out the other one. 84.
Yeah.
All right. And then the only other angle I don't have is this one right here. Use linear pair. 82. Once you have all the angles along the top using linear pair and your vertical angles to shift everything up there, find every angle. Now again, look for your corresponding. C and E. You guys see the matching 98s and the 82s? So what do I know about C and E?
Parallel.
They're parallel. And the others? See any other matching corresponding angles? Okay, so that's it. So that's how you approach fences. You fill in one entire side of the transversal and then look for corresponding. It's easier than hashtags, right? So that's this lesson. Proving that lines are parallel when you don't know if they are by using the angles. Okay? Does anybody have any questions? No? Okay. So 5 minutes left, you guys can relax. Oh, now the hands go up. What's wrong?